In this video, we're going to look at redox reactions continued. Remember that we saw redox in section 2.7 of the book. We're going to use this video to look at redox reactions for reactions we've seen in this chapter at the top of the page here, and then some new reactions at the bottom of the page. In our previous video, we reviewed oxidation states, and the carbon here on the left has 2 bonds to less electronegative hydrogen, -1 oxidation state for each of those bonds, and 0 for each of the bonds to carbon. That's why there's a -2 under that carbon. This carbon has a -1 oxidation state for its bond to hydrogen, and 0 for all 3 bonds to carbon. We will not look at this atom on this page because it doesn't react, but if we're doing oxidation states, -3 for 3 bonds to less electronegative hydrogen, and a 0 for a bond to carbon. So let's look at the first reaction we studied in chapter 6. We took an alkene and we added a strong acid like hydrogen chloride to it. This is the major product, the Markovnikov product, with the more electronegative Cl on the more substituted carbon and the less electronegative hydrogen on the less substituted carbon. Oxidation states. If we look at the beginning, we started with a -2 on the left. We replaced a pi bond between 2 carbons with this new bond to hydrogen. So our oxidation state went down by 1. We call that a reduction. Went down from -2 to -3. Carbon number 2 went from being -1 to a bond to hydrogen for a -1, a bond to chlorine for a +1. Those add to 0, and the 2 carbons add to 0 as well. We call this an oxidation because it went from -1 up to 0. So our first reaction, we had a reduction and an oxidation in the same molecule. In our next reaction, we added water to an alkene with a catalyst present, like sulfuric acid. The numbers are exactly the same as the previous example because an O is more electronegative than a carbon, as is a Cl. 3.0 for Cl, 3.5 for O. It's the same story over here. Let's copy the same story here. In our third reaction, we used oxymercuration and demercuration. Oxymercuration places the mercury on the less substituted carbon and the OH from water in the AQ on the more substituted carbon, which was Markovnikov as well. The second sodium borohydride step replaced the mercury with a hydrogen, still less electronegative than carbon. Oxidation went from -2 on carbon 1 at the end to -3 for the carbon here with 3 H's. Middle carbon started at -1, went to 0 because you replaced a CC pi bond with a bond to a more electronegative O. We say the carbon on the left became reduced. Carbon on the right became oxidized. In our fourth reaction, hydroboration oxidation, we saw that the first step put the more electronegative H, yes, H on the more substituted carbon. The other atom was boron. Electronegativity 2.0 is less than 2.1 for hydrogen. We put that on the less substituted carbon, and in step 2 we replaced the boron with OH, creating an anti-Markovnikov final result. Oxidation state on 1 ended up being -1 because you had a bond to H, a bond to O, and a bond to C, and yes, I miscounted. There was 2 bonds to H. That's two negatives there, and 1 positive and a 0. Ending up -1. This carbon here went from -1 to -2. Here the reduction is that carbon. The oxidation is this carbon. All the oxidations on this top part of the page went up by 1. And need a little more room there. And up by 1. Every reduction on this page went down by 1. So the net change in every molecule on this page was 0. So all of the reactions involved up here involved a net change of oxidation of 0. They are not redox reactions. Other reactions we encountered during Chapter 6: halogenation of alkenes. The oxidation state on carbon 1 changed from -2 to -1. That's going up by 1. That's an oxidation. Carbon 2 went from -1 to 0. That also is an oxidation. And we also studied the halogenation of an alkene in the presence of water. It's called Halohydrin formation. And similar story, O is more electronegative than carbon, just as chlorine is. Same story entirely over here. Both atoms oxidized. We'll talk about the net result when that occurs shortly.